So the last topic in geometry that we're going to be dealing with is volume of shapes. So we have volume and prisms are some vocabulary words. So volume you're probably familiar with, we talk about containers, how much liquid they hold, so we have liquid measurement like gallons and quarts and liters if we're talking about the metric system. But here, when we talk about volume, we're talking more of a cubic measurement. So we're measuring volume by cubes. So how many cubes can be placed inside the object based on the dimension. So if we're talking inches, we're talking cubic inches, or feet, a cubic foot, or yard, a cubic yard. So the shapes that we're going to be dealing with are what we call prisms. You may be familiar with this because, prisms are like boxes and cans and cylinders and pipes. These are the ones you're more familiar with. So a right rectangular prism, would be the shape of some type of box. A right circular cylinder, that would be our cans, or, for us in other areas, you would call it probably a pipe, things like that. Some oblique prisms we have is ones where we don't really have right angles, but we have more of a slanted angle look. So we have these shapes here are oblique prisms. But we're mainly going to probably focus on these top two, the right prisms. So we're going to be dealing more with boxes and cylinders. So the formula to find the volume of a right prism, it's going to be basically the area of the bottom times the height. So again, B is going to be the area of the base or the bottom shape, and you're going to multiply it by the height of the prism or cylinder. So if I want to find the volume of this triangular prism, what I got to do is find the area of the bottom, or the area of the top for that matter, because the thing about a right prism is the top and the bottom are the same shape. So notice that the bottom is going to be this triangle. So to find the base area, so our volume is going to be base times height. But first I have to find the base area. And since it's a triangle, we would have to multiply 1/2 base times height. So the base and the height have to be perpendicular. So it looks like the 2.6 centimeters is the base, or I think the 2.6 centimeters is actually the height, and the 3 centimeters is actually the base. So we would have 1/2 times 3 times this 2.6. And that's going to give me the area of the base. So if we use a calculator for that, we have 0.5 times 3 times 2.6. 1/2 is too hard to type in sometimes, so just use 0.5 instead. So we're going to get this 3.9 for the base area. So it's going to be 3.9 square centimeters. So to find the volume, we're going to multiply 3.9, which is the base area. We're going to multiply that by the height, which is the 15. And that'll give us our cubic dimension. So if we multiply our answer by 15, that'll give us then this 58.5 as our volume. So our volume is going to be then 58.5 cubic centimeters, which we write with the power of 3. So if I want to find the volume of a cylinder, again, we call this a right circular prism. So the volume is going to be base area times the height. But notice how the base is actually a circle. So we can actually modify this to pi r squared times the height. So we can just make this one formula. So we have pi times the radius. Notice that the radius would be the center to the edge. That's going to be 5 divided by 2. 5 divided by 2 would be 2.5. So I have this 2.5 squared, and we're going to multiply that by the height, which is going to be the 4 inches. So that would allow us to find the volume of a cylinder. So if we do that math, we're going to have second pi times 2.5 squared times 4. That's going to give us then this 75.78 point. Oops, where'd that go? So if we round that to the hundredths place, that's going to be 78.54. So we have 78.54 cubic inches would be our volume of that cylinder. Some other shapes we want to talk about are cones and pyramids. Cones are kind of like cylinders, but they're kind of not a full cylinder. So notice how we have these slanted edges that come up to a point that's called an apex. So we have the slant edge, we have the height, and we also have the radiuses across the bottom. So notice at the bottom of a cone is actually a circle. So we have that going on there. There's also this pyramid. A pyramid is a three-dimensional shape. Again, we know what pyramids look like, but some things that we talk about are lateral faces. The faces are like here we'd have if the base is a triangle, this would have like 3 lateral faces. Notice how again it has an apex. Notice how the altitude is actually from the top. It's perpendicular to the base, so it goes straight down. It actually, notice how it's actually in the middle of the base. So notice how again we use this base, and instead of using height, we have this word altitude, but altitude is also going to be the same thing as the height. So anyway, what happens is we discover that a cone and a pyramid are basically the third of a volume of right prisms. So we have this formula that says the volume is equal to 1/3 times the base area times the height. So again, that capital B is the area of the bottom times the height. So if I want to find the area, or I'm sorry, if I want to find the volume of a pyramid that has a height of 28 centimeters and it has a square base that is 15 centimeters on the side. So what they're saying is the base is a 15 by 15 square, and the height is this 28. So since this is a pyramid, our volume is going to be 1/3 that base area times the height. And since the base is a square, that's going to be 15 squared. That's how I find the area of a square, side squared, and then times the height, which is going to be this 28. So from here, if we want to use our calculator, we can kind of put that in. So we have not 1/3, but that should be a 1/2. Sorry about that. That should be 1/3. So let's use the fraction button, alpha F1. So I have 1/3 times then 15 squared times then the height, which is the 28. And we get this 2100 as our volume. So again, volume is measured in cubic units, and they were talking about centimeters here. So this volume would be 2100 cubic centimeters. Now, if we were doing a cone, the volume could be modified to be 1/3. Since the base is a circle, we could say pi r squared times the height. Since the base is a circle, that's the area formula for a circle. So you could also use this formula to find the area of a cone, is just change it to pi r squared. So you need to know the radius and the height of the cone to determine the volume of the cone. Okay, so that concludes this scenario a little on some volume.